In your supplement for 4.2, we're applying what we know about inverses to tables. And if you remember, we know if something is invertible, if every x has one y value and every y has one x value. So it needs to be 1 to 1, which means that none of your x's can show up more than once and none of your y's can show up more than once. So on the number 1, if you notice, our x's are all different and they map to different y's. Nothing shows up twice on the m of x row and nothing shows up twice on the x row. So this one is invertible because it is 1 to 1. So that would take care of your first question right here. As to is it invertible and why. So it is because it's 1 to 1. And then after that, we need to construct a table of values for the inverse. So all we need to do for that is make a table, and we're going to have x, and then we're going to have the inverse of x using our proper notation with for inverse. And with the inverses, if you remember, we're reflecting over the line y equals x, and when that happens, the x's and y's in reverse. So in this first column here, instead of 1, 0, it's going to be 0, 1. And then each of the columns, the same thing's going to happen. So instead of 2, 5, we're going to have 5, 2. Instead of 3, 10, we'll have 10, 3. Instead of 4, 15, we'll have 15, 4. And instead of 5, 20, we're going to have 25. And so that takes care of number 1. Now, if you look at number 2, for the question, is P invertible? We have all of our x's here showing up once, so that's good. There's no duplicates, so it is a function. However, for it to be 1 to 1, we have to have all the y's be different also. And if you notice right here, the 2, 0 and the 4, 0, the 2 and the 4 both map to 0. And we can't have that happen for it to be 1 to 1. So this would not be invertible, and the reason why would be because it is not 1 to 1. And that's your supplement for section 4.2.